We are going to talk about arc length and surface area. Now, if I gave you two coordinates, you could find me the distance between those two coordinates. Yes? Linear distance. You are off that. You've known how to do that since like 7th grade, maybe even earlier. I don't know.
What?
Okay? The distance between two coordinates. Right, we've known that for a long time.
Oh, yeah. We can also count.
Glad we're on the same page. Okay. Now, what if I want the distance along a curve? So I have a piece of string just laying there. Okay. Can we calculate the arc length, aka the distance along that curve in some way?
Yeah.
Okay. Now, let's talk about the distance formula. If I'm finding the distance between 2 points, how do we do that? Plus y minus y.
Do you have initial twice? Oh, it's initial minus 1.
Okay, it's just funky notation, okay? X, xi, and xi minus 1, okay? Now, what is another way to describe x1 minus x2 or x2 minus x1? We like to call that like, well, how about change in x? Right? So this I can call change in x squared, right? Plus change in y squared. Do you agree?
Yes.
Now, Peter, I can see my scroll bar, but my scroll bar doesn't work. Yep.
Is it because you're holding the marker?
Nope.
Is it with the...
I don't know. But anyway, we'll worry about that later.
Yes. Yes.
So, now what I'm going to do, I'm going to multiply by 1. When I multiply by 1, let's talk about what happens. I'm going to bring this delta x squared as a denominator and multiply it to this delta x squared. It becomes 1. Plus, if we take the denominator and distribute it through, we have change in y over change in x squared. But then we didn't distribute the numerator through, did we?
No.
No. But if we take the square root of delta x squared, we have delta x. Okay. So up here, I did like this really funky notation, right? That's any arbitrary x value. Okay, and so if we take all of these arbitrary x values along a curve, okay, we find their minute change in distance, right? And we add them all up. Where's this going? Okay, we add all of these individual lengths, we sum them up by taking the integral from a to b, square root of 1 plus f prime of x squared dx. You don't necessarily need that I, just f prime of x will be fine. This is how you find arc length. Because over here when we wrote delta x over delta y, right? That's like the derivative, right? Okay, and so you're just gonna write f prime. Okay, so to find arc length, you're gonna find the derivative, plug it into 1 plus the square root of 1 plus that derivative squared, and then we'll have to decide if we can integrate by hand or if it's a situation that we need to use our calculator for. Okay? Some of these we're going to be able to do by hand. Some of these we do not have the skills yet. So let's look at this one. This is one that we are going to be able to do by hand. I'll just tell you that right now. Okay, so our interval is 1/2 to 2. Like right here. Like that, this little piece right here. We're going to measure that length. Okay? And our equation is x cubed over 6 plus 1 over 2x. So the first thing we need is our derivative. Derivative of x cubed over 6. X squared over 2. The derivative of 1 over 2x. Negative 1 over 2x squared. Okay. So now our arc length is the integral from a to b of the square root of 1 plus our derivative squared dx. We should. Okay, Austin said if we're doing this by hand, shouldn't we square it? And yes, we're going to need to. Now, do you see that there's kind of excuse me. Do you see that there's kind of a pattern with that f prime? X squared over 2 minus 1 over 2x squared. There's kind of a pattern, which means this could actually be nice for us, all right? So, you're going to need to really be able to recognize patterns to be able to integrate ones like this, all right? So, if we take this binomial squared, what would our first term be? X to the fourth over 4. Okay? And then we have a times b twice. What is a times b? Negative 1/4. It happens twice, so negative 1/2. And then what would our last term be? B times b.
X4 shouldn't that be X4 over 2? Because that would be X4 over 4 plus X4 over 4.
What? We're talking about?
Shouldn't the first term be over 2?
X squared over 2.
Oh, no, never mind. No.
Okay. Okay. We're good then? All right. So this is what I want you to notice. If we were to combine terms, we would have x to the fourth over 4 plus 1/2 plus 1 over 4 x to the fourth. I've underlined 2 pieces with my black marker. Anything you notice about those 2 pieces? Okay. This middle term, here is negative, here is positive. So I need you to be able to make the connection that we can factor this to x squared over 2 plus 1 over 2x squared, the quantity squared. Since we have the same pattern happening, except that middle term is now positive, we can factor it to just be the conjugate squared. Do you see that? Why is that helpful? Okay, we have the square root of something squared, right? Okay. Sometimes it's the obvious things, right? Not obvious? Okay. Okay. All right, so what is the antiderivative of x squared over 2?
1/6x.
Antiderivative of 1 over 2x squared.
-1/2.
Evaluated from 1/2 to 2. Wasn't that cool? How the algebra worked out? Some of us appreciate it at least. Okay. All right. Plug in 2, plug in 1/2. Let's see what this is.
Make it the same.
Yep.
864 minus.
We can get, we can get.
Did I add those?
You should get a negative number, or positive, negative number in here.
Under the decimals. You get.
That should be. Oh, sorry, not 87, 97. You get 87.
99.48 produces that with 33.
Oh.
Right. Oh, it is a
99.48. You should have, what, 8 over 6 minus 1/8. Nope, 1/16. Nope, 1/4. Try again, Mrs. Holly. 8/6 minus 1/4, right? And then you're subtracting the 148, subtracting negative 1.
One of the ones they use at graduation all the time.
You plug in 1/2, that becomes 1.
And then the other one becomes 1.
Over 48.
I don't think this will be giving anything away. But
You just get it for everyone. If you got like,
you know how
you get
like
all of the
One
classes.
for each super rare.
All the other
and
classes.
then one where it's make a fraction.
I did
Alright, so.
Yeah.
Because what happens during homework?
I don't think you should get their graduation.
Number 35?
I think so.
Well, but what Grayson brought up was actually like his calculator made it a fraction, but it was an irrational number that it made a fraction out of.
That's what I asked him about. I remember that now.
Yeah, that's what happened.
All right, did we get our 33/16?
Yeah.
Okay, now on a quiz type situation, probably the 1/2 to 2 is not what I would be asking you to do here. All right, maybe more of like a 1 to 2, maybe. Alright? But it's good for us to practice that. Now, if we actually were to find the straight line distance between these points, okay, I'll tell you right now that if you plug in 1/2 on that graph, you would be at 49/48, okay? And if we were at 2, we would be at 19/12, okay? So if we do the distance formula, and I already did this for you, okay? But if we do the distance formula, we get 1.602. What does 33/16 approximate to be? Almost 2. If our straight line distance is just over 1.5, and our arc length is just over 2, does that make sense? Yeah, your arc length should be longer, right? Especially if it's, we had that dip, okay? It's kind of like walking on the sidewalks versus like flying like a bird, right? Sometimes we have to walk a lot longer than as the crow flies. Sorry, I should have said crow. Okay. All right, another example. Why is everybody so whiny
They
today?
don't like the.
It's almost whiny Wednesday.
But it's terrific Tuesday. Terrific.
Start with the terror.
I'm gonna start wearing my Math Club shirt every day once I get it.
Avoid natural logs.
Avoid negative.
This is the shirts for Math Club. It needs to be our motto in here.
Be responsible.
That's not one of the class expectations.
She's gonna
Okay, do you have this written down? Okay, first thing we need to find is what? Derivative. Now, all of you are being super whiny about the natural log of cosine, but let's take the derivative. 1 over cosine times. Oh, you're still going to whine. Still going to whine. Okay, good to know. When we go to calculate our arc length from 0 to pi over 4, we're going to take the square root of 1 plus the derivative squared. Still so unfortunate. Yes.
Oh, this is dumb.
I don't know. It's,
And the formula?
1 plus change squared
is it-
is,
I think I missed that one.
Sine over cosine.
because, alright, so that's it.
Oh. Yeah. I remember now.
Okay, Isaac. 1 plus tangent squared.
Yes?
1 plus tangent squared
Oh,
is?
I wouldn't be saying.
Secant.
How can we rewrite 1 plus tangent squared?
That's over.
Is it that one thing?
Probably is.
Trade items.
But I didn't just go over those.
I was just talking about it.
Or no, I
It
was
was like 3 weeks.
Okay, side note.
That should have been on February Monday.
No. That was.
Okay, we know sine squared plus cosine squared equals 1.
Yeah.
If we divide everything by cosine squared,
Yeah.
sine squared over cosine squared, cosine squared over cosine squared, 1 over cosine squared. Isaac, What is 1 plus tangent squared?
That's tangent squared plus 1.
I would have just,
Okay.
if I just guessed.
Wait, are you on?
Allowed to do what?
Wait, can you just put that in secant?
Since we are going from 0 to pi over 4, the square root of secant squared is secant.
Oh, you have to do the other version now too.
What is the antiderivative of secant?
So that's natural log.
Oh, sorry.
Look it up in your book. Somebody grab their book and look it up.
Or you looking at calculator. Where is it?
I know this is derivative.
Oh, that's ln of secant of x plus tangent of x.
Whoa.
We would have never got
That's not what I thought.
We would have never got it.
It would be 1 over cosine. That's all.
You want to stop thinking about it now? Okay. So we have the natural log of radical 2 plus 1 minus the natural log of 1, which we'd have to approximate with our calculator anyway. Okay, some of these are going to work out very nice to do by hand. Some of them are not going to work out very nice to do by hand.
Will we need to know that?
No, you will not.
Will we ever need to know where they want?
No.
It's gonna be a little
No.
bit.
Like, no. Future in like.
It would be something that you would be able to look up.
Yeah,
Like right there.
yeah.
But you won't need to be arriving at any point. How long?
What's the answer to this math problem? Siri, go to Slater math. Slater.
Okay, now arc length is an AP topic. All right. Now I'm going to introduce you to surface area, but surface area is not something that pops up on the AP test. However, we've been doing these volumes of revolution to find volume. Why can't we also find the surface area of these objects? Okay, I feel like surface area is a very applicable thing to know. Can you please put Siri away?
Siri can do it.
Siri can do it.
My
You don't
cell
need
phone
enough
child.
calculus.
But there will be no life. I can't believe Siri can do it.
Okay, so just
It'll help me out all
take a break. Let's talk through this. Okay, consider a curve rotated around the x-axis. Okay, if we take like this little chunk of arc length right here, and we rotate it around the x-axis, we have like this band, right? Kind of like a rubber band is kind of what it looks like, right? And so we have like this 2 pi r as our circumference, but then it has some thickness to it. All right? So the radius is the y value of the function, so like the function value, okay? And by adding up all of the circle circumference, okay, we get area of 2 pi y. Now, 2 pi y dx. Now, what is this dx? What did I say this was when I pointed it out? Arc length. Do we know how to find arc length?
We do now.
So we're going to just replace that ds with arc length. So what we have is 2 pi r times the arc length. And that gives us the area of that rubber band. Add them up all together, aka take the integral, all right, add them up, and we have all of these rubber bands added together to get the surface area of this rotation. Put Siri away.
It's so handy. I've never used it before.
Do you watch The Big Bang Theory?
No.
Okay. There's an episode where Raj like falls in love with Siri.
It's like making fun of her.
Making fun of her?
Like the movie her.
The movie her? What?
This movie called Her.
There's a movie called Her.
Yeah,
Okay.
it's like,
Where he like falls in love with his like personal assistant, like just the voice.
Oh, I know what you're talking about.
Okay.
has anybody seen Lucy?
That's a weird.
Scarlett Johansson.
That's a
Oh, yeah, I
weird
did.
movie.
All right. One example, and then I'm gonna give you the last part of class. Did you not get it written down?
Yeah, I did.
Oh, okay. Last example. So maybe you should write it down, f of x equals radical x, and we're gonna rotate about the x-axis.
Oh, the last. Is that a mark on the smartboard or is it drawn?
Do I just make her like a single?
It's drawn.
Like a,
Oh, it's.
Okay? And we're gonna go from 0 to 9. Yes, I'm sure you were. Okay, so first thing we need is what?
rectangle that's the
How are we gonna do this?
Yes. Would that be like 3D? Would it have to come out of
You do not need to, you do not, yes, yeah, because it's three-dimensional, right? Like we're rotating it, so it's creating this three-dimensional figure that we're finding the surface area for. Okay, we're all very good at finding the volume, right? Now let's also find the surface area, okay? So, first we need the derivative of radical x, which is? Okay, so our surface area is the integral from 0 to 9 of 2 pi y surface area. So 1 plus dy dx squared dx. All right, I'm going to move 2 pi out to the front. I have two radicals that are being multiplied, which means we can do what? Multiply what's underneath, correct? Okay. So we have one radical that is x plus 1/4. Okay. So we have 2 pi. We know that this is like x plus 1/4 to the 1/2 power, right? So it's going to become x plus 1/4 to the 3/2 power times 2/3. What? Okay. So what we have is 4 pi thirds times 9 plus 1/4 to the 3/2 power minus 1/4 to the 3/2 power, and then we would, on a non-calculator type of situation, you would leave it like that. If you had your calculator, you could figure that out for you, right? Or Siri. I don't think Siri can do this.
I'm
Oh.
ask that.
Ask her what is 9 plus 1/4 to the 3/2 power.
What is 9 plus 1/4 to the 3/2 power?
All right. All right, I'm going to give you the last 10 minutes to work on. So, and I think I have it written like this on your gold sheet. Correct me if I'm wrong. I give you non-calculator problems and calculator problems. Okay? I challenge you to get 3 done.
Yes, number 3.
Get 3. Erase it.
Do you want me to put the stuff on? Wait.
Yeah. Let me go ahead and stop recording this.
50,662 over 128.
I hope someone watches these notes later.